coming to you with an interesting definite integral here. This integral has lower limits of integration of 1/3, upper limit 1/2, and it reads x times the fractional part of 1 over x times the floor of 1 over x. Now, there's a couple of intermediate results we can state that'll make this a relatively straightforward integral. Let's take a look down here. Notice here that I have a result that gives the floor of 1 over x in the interval that corresponds to the limits of integration here. Now, let's just take a look at why these statements are true. It's basically true because the 1 over x function is a decreasing function, all right? And that's why the values occur in this particular order. Now notice it's very easy to believe this is true for 1/2. If you put 1/2 in right here, you get 1 over 1/2, which is 2, and the floor of any natural number is the natural number back. Now notice we have to exclude 1/3 because if we put 1/3 in for x, we would get 3 right here. Okay, but just maybe a simpler example here. Let me just show you a concrete example rather than talk about it. Notice that 5 over 12 is contained in this set. And when I say contained in this set determined by these limits of integration. So let's go 5 over 12 is a member of the open 1/3, closed 1/2. Okay, y'all, that is a 1/3 right there. So we have 1/2 closed here. Again, y'all, this is 1 divided by 3 right here. I don't want to take the time to try to erase it. Now notice that 1 over 3 is the same as 4/12, right? Then 1 over 2 is the same as what, 6/12? So 6/12, if you add this to this, you get 10 over 12. Right, but remember the midpoint would be just that divided by 2. In other words, 10 over 12 is 1/3 plus 1/2, right? Okay, 1/3 plus 1/2. I'll just go ahead and write it down. 1/3 plus 1/2 is the same as 10 over 12. Okay. And that's straightforward enough. This is 4 over 12. This is 6 over 12. 4 over 12 plus 6 over 12 is 10 over 12. And half of that is 5/12. So 5/12 is actually the midpoint of these limits of integration, right? But notice that the floor 1 over 5 over 12 is the same as 12 over 5, right? And I'll leave that step out just in the name of avoiding clutter here. But, okay, now if you do the floor of that, see, if you do the floor of that, you do get 2. And again, I left out the step that this is equal to the floor of 12 over 5, and you round that down to 2, right? Now, let's take a look at how that would work with this fractional piece right here. Now, this one's a little strange. The fractional piece returns a number between 0 and 1, and it can return the 0 too if it's an integer. But anyway, again, in a similar fashion right here, 1 over 5 over 12, and I'll just come 1 over 5 over 12 would be 12 over 5, right? I'll just write that down again. I don't have as much space as I would like here. Okay, so that's 12 over 5, right? Again, folks, I took this 5 over 12, which is contained in this set, limits of integration. The reciprocal of 5 over 12 is 12 over 5. Now 12 over 5 minus 2 would indeed return a fraction, 2 over 5, right? So it works. And that's now this, you may think, God, this is overkill. You're right. If we're just doing numbers in our head, we wouldn't be going to the trouble to write all this down, but we need to be able to represent this in the integral, right? So what's going to happen is x will remain unaltered. Okay. Now this fractional part of 1 over x will get replaced by this part right here. It'll physically get replaced by 1 over x minus 2, right? And then 1 over x will just get replaced by the constant 2, since it's always equal to 2 in this for these limits of integration, right? So again, y'all repeat at the risk, the 1 over x needs to be replaced by something that we're familiar with, right? Right now, who knows how to integrate this, right? But if we replace the fractional part of 1 over x with 1 over x minus 2, and the floor of 1 over x with 2, that's what we're going to get here on the next page. Let me clear this out and let's move along to the next page. Okay, you see, y'all, that's exactly what happened. Now, no, apologies, it's hard to keep everything on the same screen for me, but you see how x right here stayed the same? And we replaced this, which is the fractional part of 1 over x, with what I just talked to you about. We replaced it with this, okay? And then also the floor of 1 over x, we replaced it with 2. Again, I know this is having to keep track of stuff, but again, this piece right here got replaced by this because it's going to be easier to integrate. And then 1 over x, the floor of 1 over x got replaced by 2 on this next page. Okay. Now that gives us something that's very, very straightforward to integrate. And I didn't go, the antiderivative for this object, if you think about this, this is x times 1 over x, which is 1 minus 2x. Its antiderivative is this part right here in the brackets. And the 2 just comes outside. That's a property of integrals. The 2 comes outside. And y'all, what this notation means is just to evaluate this part right here at 1/2. And then, you know, you'll have that as a number. And then you subtract that from whatever you get when you evaluate it at 1/3. And then you multiply by 2. And again, I left out the steps. Those are arithmetic. And most of y'all that are watching this don't need to see that. But this is just a symbol to represent how you evaluate an integral. And we leave out some of the details. But anyway, it's pretty straightforward, actually. And the result of the integral is 1 over 18. Okay, I hope that helped.